Hello, welcome back to Python and welcome back to Numpy. I hope you are in the right mood of coding and you are as excited as me because today we are gonna handle three new functions, or no, two new functions and one old function. But what we are gonna do, we have this array we already had in our last video, but now we simply want to make a one-dimensional array out of this array. And how to do that, I will show you today. So I guess I accidentally deleted one square bracket. No, I didn't, it's printable. So let's first create a NumPy array out of our old array. And as you see, there are many dimensions. It's a 4-dimensional array. We want a 1-dimensional array, so we are just typing OO equals AA point Reshape, not Ravel. But yeah, it's written like that. And now if we print pp, we are getting a 1-dimensional array. So you can imagine it is sorted like, every square bracket was deleted except the first and the last one, because otherwise it wouldn't be an array. But every other square bracket is deleted now. And we can even define an order. At the moment we are just using the native order, which should be C. Yes, it is. And as you can see, he's just starting with the first element of the first 1-dimensional array, goes to the second 1-dimensional array, so on. What we can also do, we can type an FSN keyword for an order. And yes, now you see the order is quite different, because after the 1, which is the first element of the first 1-dimensional array, he jumps to the second 3-dimensional array, looks at the first 1-dimensional array and prints the first number. Then he goes in the next 3-dimensional array, printing the first number, and so on. Then 122 is in the fourth 3-dimensional array, the first number. And after that, you could think he goes to the 6th, but no. He will get to the next 2-dimensional array and is printing the 11. Then he will also get to the next 2-dimensional array of the next 3-dimensional array. And getting the 411. So if you had a 2-dimensional matrix, he will, using F as an order, he will usually use the columns instead of the rows. But because we have a 4-dimensional array, it is kind of more complicated. So just keep in mind, first element, first element, first element, first element of the 3-dimensional arrays, and before he uses the second element, he will jump. Then again he dives in, but now he skips the first 2-dimensional array, heading to the next 2-dimensional array, does it with every same of the 3-dimensional arrays, then the third 2-dimensional array, and then after, it should be 271, we'll finally head to the second 1-dimensional array of the first 2-dimensional array. So 6 is after he got everything out of the 2-dimensional array, at least one number of each 2-dimensional array. Then he finally reaches into the 1-dimensional array. It's like being as much diverse as possible. You can maybe, use that as a quick reminder. So that to the orders, we have a similar function which is called Flatten. Does the same, except it makes a new copy of our array, making it a little bit less efficient. But on the pro side you get a copy. And yeah, if we don't want an exact order, we can just use reshape. Reshape we had in our last video. What we are gonna do, we want a one-dimensional array, so the tuple has only one element, and -1 means he should fill it so that the tuple is able to be a shape tuple. So for example, if you have 2, he will set up this one-dimensional arrays so that the shape is possible, the reshape. And yeah, of course, -1 will be always possible because he can stuff everything into a one-dimensional array. And that does everything the previous functions did, but with the C order you can't have the F order in this one. Okay, this is everything for today's topic. I hope you liked the video. See you on the next video. Bye bye. Have a nice evening, day, dinner time, whatever time it is, and bye bye.